Alright, so CE is CD plus DE. So CE is this one, right? This one. So it's CD plus CE, and that is A and this is B. That's why CE is A plus B. Now, because we are going to deal with CX later, so I want you to notice that CX is this one here. Okay, so if you want to find CX, you found CE already, right? So CX is like a part of CE, and we don't know how much, so we assume we let that be X. Okay, so CX is like X times CE, and if you expand this is what you should get. Okay, so that's one form of CX. All right, and then I did this fx and xm, but that's fx is like, because we figured out what is fm, right? You did that yourself, so fm is that one. So fx is part of it, and fx is like n parts out of the n plus 1 parts. That's why I don't need to let that be y or z or anything. So like, you know how here I let this be x, but here I know the ratio, so that's like n parts out of n plus 1. So that times fm, you can figure out what is fx, okay, in terms of n. All right, so and then xm, you can do it the same way. You know, it's 1 part out of the n plus 1, so you can do that and expand it, you'll get xm. Although I don't think we will use it. Depends which cx you end up using, so you might not need to even use this one. Okay, so cx is done this way. So cx, I choose to do it the easy way, so it's cf and plus fx. So fx is this bit, and cf is the opposite direction. So this was fc, right? A minus b. So cf will be b minus a. Okay, so this is cf over here, and this is fx. So if you add them up, like, you know, you have a fraction over here, you have like, you can assume this is like whole numbers. So to make them all over n plus 1, you need to multiply this cf by n plus 1. So n plus 1, and then b minus a, and then you will have n, and then 2a minus 0.5b. All right, and then you keep expanding it, so it becomes nb plus b minus na minus a, and then expand this, you get 2na, and then minus 0.5 nb, and then it's all over n plus 1. And then if you factorize it, because you want something a and plus something b, okay, and they both will be over n plus 1. So b, we have n plus 1, n plus 1, and then minus 0.5n. So you will end up having 0.5n plus 1. This is for b, the coefficient of b. The coefficient of a will be, this is negative n minus 1, and then we have plus 2n. So this will be n minus 1. So that is the coefficient of a. So if you split the fraction, you get n minus 1 a, n over n plus 1, and plus 0.5 n plus 1 b over n plus 1. I hope that is all making sense. I'm sorry for the noise. So if I just rewrite this again, so let me use another one. So all this was the coefficient of a, and all this is the coefficient of b. So if you look at the other x, so we had the coefficient of a and the coefficient of b. So this is, if you notice, this is also for cx, and this is also for cx, this expression. So that means my x, I'm gonna erase this bit. Okay, so this x can equal to so the coefficient of a over here, the coefficient of a over there can be the same as the coefficient of a over here. So n minus 1 over n plus 1. And then if you notice the coefficient of b, again you have x over here, right? So x, but you have this expression over here, 0.5 n plus 1 over n plus 1. Okay, now if you notice one thing, this is an expression for x, this is also an expression for x. So basically it's this equal that. So if you write that out, expression 0.5 n plus 1 n plus 1. Okay, so you have your algebra equation here. Now think of them this way. So this n plus 1, you can move it to the other side. It's being divided here, so when you move it to that side, it will be like times. So what happens is that you no longer have this, and then you have that other n plus 1 over here, n plus 1, but it will be the same like above and below, so you can cross them out. You can cross them out with this one. So you're just left with n minus 1 equals 0.5 n plus 1. And then you move the 0.5 to the other side, because we only have 1 n over here. So you move it to that side, it becomes 1 n minus 0.5 n. You're left with 0.5 n. And this minus 1 goes there, you get, this is positive 1. So positive 1 plus 1 is 2. And then therefore you will get n equals 4.